Hey, boys and girls, good morning. It's been a while since we've done one of these videos, but I wanted to make sure that you had a good understanding of subtracting mixed numbers, and especially ones where you need to do some regrouping. So, we're going to look at the pair deck problems that I'm going to leave for you, and I want you to work on them. And when you're done with them, I want you to take a look at this video some more. And maybe review what you did, and then also try to work on the journal pages as well. Okay, so your problem, and I'll move my head out of the way here, says the art students had 3 and 2/3 gallons of paint for the school play scenery. They used 2 and 1/3 gallons. How many gallons were left when the students finished painting? And we're going to write a number model and try to draw a picture or a number line or something that's going to show your thinking and how you calculated this answer. Okay, so that's our first question. And we have a second question too. And it says, Jana bought a 5 pound bag of potatoes to make potato pancakes. When she finished cooking, she had 1 3/4 pounds of potatoes left. How many pounds of potatoes did she use? And again, try to show a way to show your thinking. Okay. So we're not going to work on these problems for this video. I want you to work on them on your own. But the tools I'm going to help you with, or the strategies I'm going to help you with, them hopefully will help you understand these questions a little more. But I'd like you to solve or work on these before you continue this video. I'd like you to think about trying to do it first on your own. Try to think about how you're going to go about solving these problems. Think about ways that you would work through them without any of my teaching ahead of time. And then take a look at what I show you and see how it compares. See how you maybe use some of my strategies already, and maybe you didn't. And maybe we want to fine tune some of this, or maybe it's just fine the way it is. So think about that, work on these two problems, and when you're ready, we're going to come back and continue. Okay? So let's come up with a problem. I'm going to make up a new one so we can work on it. All right. And I'm going to use this whiteboard tool. Hopefully, it will work properly, like it always does, right? So we're going to work on a problem to start that's going to be pretty straightforward. We're going to do 4 and 3/4, and I am going to dismiss that because I'm just using it as a whiteboard, minus 2 and 1/4. And there's an algorithm. We can work through the algorithms in a few different ways, but let's take a look at maybe visualizing it first. Okay, so we're going to go over to our toolkit. And we have the red circle as the whole here. So we're going to put that up there. And we have 4 and 3/4, right? So I'm just going to trash that really quick. Now, we are taking away in subtraction, right? We don't like necessarily to say take away, but that's essentially what we're doing. We're kind of reducing the amount of that we're starting with. And finding the difference between one number and another is another way to think of it. And so there's a couple different strategies. There is the strategy of starting with the whole amount and then actually taking away what we have. There's also a strategy of starting with that lower amount and seeing where the difference is and how much we need to add to it to get the larger amount. So this is 4 and 3/4, right? And we're subtracting 2 and 1/4. So we are going to take 2 and Should I trash them? Nah, let's just leave them over here for now. And we're going to take also 1/4 away. And what do we have left? Well, we have 2 and 2/4. That's what we have left. Not so hard, not so bad, right? Now, this is a particularly easier one where we didn't need to break anything apart, do anything like that. But that's essentially what we did. Now, the other approach could be that we have 2 and 1/4, and we need to add to that, right? We need to start with, so we have 2 and 1/4 here, and we need to add to it so that we get all the way up to 4 and 3/4. So we'd add 2 more fourths to make 3/4, and then we'd add 2 more wholes to make 4 and 3/4. So it looks something like this when we're talking about looking at the actual numbers. So when we're doing addition, or I'm sorry, subtraction of mixed numbers, I write them out this way to just show you as sort of a problem, but you should probably work on actually stacking them up when we subtract. And it should look closer to something like this. And then we start off with the parts of the whole. This is sort of its own place value. And we say, all right, 3/4 minus 1/4 is 2/4. And then we have 4 minus 2 is 2. Not so bad. Not so bad at all. Another strategy that sometimes people do is they'll convert these numbers into fractions that are, what we call improper fractions, even though there's nothing improper about them. Just an equivalent fraction that is not a mixed number, right? So we would do, all right, we'd have 4/4 times 4, that makes 16/4, plus 3 more makes 19/4. And if we subtract that from 2 and 1/4, so we're going to say 2 times 4/4 is 8/4, plus 1 more is 9/4. And then we could subtract 19 minus 9 and get 10/4. Now, do these two equal each other? Well, let's find out. Do they equal each other? So 10/4 is the same thing as saying 4/4 plus 4/4 plus how many more fourths? 2. 2/4. So yes, they do equal each other because this is 2 wholes and this is 2/4. Now, if you simplify the 2/4 into 1/4 or 1/2, excuse me, that's great too. So that's kind of one of the easier mixed number subtraction problems. Not bad, not bad at all. But now here's the big challenge. When we have to regroup, when we have a fraction problem that looks, I'm going to add just a whole new page here. Oh, all right. Well, I am just going to erase this then and start fresh. Bloomk. There we go. All right. Now, and I'm going to make my stroke thickness just a little bit thicker for this next one. And I'll switch over to red. So what if we have a problem like, say, 5 and, let's say 1/6 minus 3 and 4/6. This is where it gets a little more complicated. And I can point out sort of a common mistake, but we're going to get into looking at it visually. And there's a couple different ways we can look at it visually. One with fraction circles. That's totally fine. But we're also going to look at it in a number line. Okay, so I'm going to clear out this right here, and I am going to insert a number line. And let's hope I do it correctly. Had a little bit of a challenge with this. So let's see. We're going to go from 0 all the way to, let's go to 6. Okay. Right. And we're going to count by 0 and 1/6. Oops. And tab over. There we go. Now, see if I can. Oops, I think I need to bring that up first. Did it work? I think it did, but it's really, really long. I'm going to fine tune this one. I'm going to make it from the smaller number to the upper number. A little bit more, a little bit less, right? So I'm going to go from 3, actually, to 6. Now, that looks a little better. And I wish I could show all of this. There we go. So with this particular problem, we are starting either at the upper number here. There we go. Right here. Or we could start at the lower number and then kind of count our way there. And the counting up method for fractions, we could say, all right, how much more do we need to get to the next whole number? And then how many wholes do we have in between? Ooh, went past that. And then how many more parts of the whole do we need to get to that next, to the next number, right? So what is the difference? What is the distance kind of in between these two? We have here 2. The E toolkit. 2/6. And here we have 1/6. And in the middle, we have just 1 whole. So 1 plus 2/6 plus 1/6 is altogether 1 3/6. So that's how we did it visually. We did it with a number line this time. You could do fraction circles again, or even like fraction rectangles, and kind of take away some and kind of see it. But I think this is a nice way to think about it too. And when we're getting into doing it in an algorithm format, this is where sometimes people can get tricked up. And when we look at this problem, there is sometimes a mistake that people make where they will look at the parts of the whole and they will just subtract them. They'll say 4 minus 1/6. And that's a problem, right? And then they would do 5 minus 3. And if we did that, we'd get 3/6 and we'd get 2 wholes. And that is no good. That's kind of like saying, all right, I have 51 minus 34 and doing 4 minus 1 is 3, and then 5 minus 3 is 2. Also, no good. So we're not doing that. Let's avoid that mistake, okay? Instead, we have to ask ourselves, can I subtract 1 minus 4? And just like in a regular subtraction problem, if you can't do it, we need to do some regrouping. And what we'll do is we will regroup this value here, the number that is the larger number. And we will change the 5 wholes into 4 wholes plus whatever this fraction is working in, whatever unit or whatever value the denominator is, that in wholes. So 1 whole in sixths is 6 sixths. And then there's one more sixth here, right? So that is still the same number, but we're going to regroup it as 4 and 7 sixths. Can we see that okay? I hope we can. Now, after that, you can now subtract 7 minus 4 is 3 sixths, which was the same number we had before, but the next one is 4 minus 3 is 1. And that was the same value that we got over here in that beautiful handwriting I did. Okay. Now, the other approach that people take, as I said before, is converting those fractions to equivalent fractions that aren't mixed numbers. So if we take 5 and 1/6 and we say, all right, how many 6 sixths or how many sixths is 5 wholes? It's 5 times 6 sixths, which is um, which is 30 sixths plus one more sixth. And then we have how many sixth is 3 wholes. 6 times 3 wholes is 18. So we have 18 sixths plus 4 more sixths. And all of that together is now 31 sixths minus 22 sixths. And when we subtract that, we can say 31 minus 22, that's 9 sixths. And that is the same thing as 1 and 3 sixths. So this was pretty quick, but I covered a lot of different things in a small amount of time here. What I'd like you to do is, where is it? There it is. I'd like you to work on this page and try to use some of the strategies that I talked about. There are going to be some problems that you do need to regroup with. Number 2, for example, says 6 and 7 tenths, 1 and 9 tenths. So we're going to need to think about that. And also down in the extra problems here, there is something that does require some regrouping. So try those strategies out and let's see how it works. Okay. I hope to see you tomorrow in person, Pod B kids. And yeah, I hope that we can all get back to normal with this real quick. All right. Have a great day, and I hope to see you soon.